All right, so on the page that says factoring polynomials, we are only going to do part of it today. We're going to just do the first box that says GCF. Who knows what GCF stands for? Right. Greatest common factor. Okay. Greatest common factor can have a numerical part, what we call a coefficient, and can have an algebraic part. It can be to the first power, second power, third power, whatever power is the greatest power that's going to go into each of the terms without messing it up, right? So, for the GCF, you always want to check for the GCF first. It's the very first thing you do. Whether you have 2 terms, 3 terms, 28 terms, how many ever terms, you always want to look for the GCF first. Okay? So on box number 40 right here, we have 28W and 12. So 2 is a common factor, but is it the greatest common factor? So 4 is greater than 2. So sometimes you may need to do a factor tree, you know, the little tree thing we did last week. You might need to do one, but this one is 4. Then you're going to draw your set of parentheses, so you're going to make it look like you're supposed to have to do the distributive property next, right? So what would you multiply 4 by to get to the 28W? 7W. And then what would you multiply 4 by to get to 12? 3. Okay, so factoring in this case looks like we are undistributing it, right? And now, when you look at it, now it looks like you need to do the distributive property, okay? All right, box number 41, what's the GCF here? Well, there's no numeric GCF because there's a 1 here and there's a -3 here, so no numeric part, but definitely A to the second, B to the first, right? Okay, let's see what we're left with. From the first term, what are we left with? Just A to the first. And for the second term, what are we left with? -3. All right, box number 42. Make sure you get the greatest common factors, because some of you are about to give me a common factor. Make sure you've got the greatest one. 6 is a common factor, 9 is a common factor, but neither of them are the greatest. So what do you think it could possibly, what do 6 and 9 both go into? 6 and 9 both, well, 6 goes into 12, but 9 doesn't go into 12. 6 and 9 both go into what? 18. So if you take 36 and divide it by 18, goes in there evenly, goes in there twice, and you take, 54 and divide it by 18, goes in there evenly 3 times, okay? So the numeric part is 18. Then we've got an X and we've got a Y. So X to the what power? First, and Y to the second. Oh, there's also a Z, but it's not in both. So there's a Z here, but not here, so we can't have a GCF of Z. All right, so our GCF is 18xy to the second. That leaves us with what for our first times? How many times did 18 go into 36? 2. I just did it on the calculator, right? X to the 4th, because this coefficient, if you want to write a 1 there, plus the 4 should add up to 5, right? Y to the what? first. Oh, and got to squeeze in that z. Minus, how many times did 18 go into 54? 3. And then xy squared. Okay?